Hello everyone, we are at Beyond the Formula. Let's see why banking of roads is necessary. So in the previous video we have seen what that why does a cyclist lean, right, while taking turn, right? So what was the result? To prevent fall or toppling, right? And balancing the torque. So balancing torque, right? And another center of mass alignment, right? That was the few topics involved in the previous topic, right? Now let's see why banking of road necessary, right? So you see the main idea behind this, it is not similar to the leaning of cyclist. It is main idea is what? Main approach here is to reduce dependency on friction, right? Making safe turns at high speeds and preventing what? Preventing skidding, right? Let's see how. Suppose 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 there is no friction. Suppose there is no friction between tires and road. Now if there is no friction between, can a car take a safe turn, right? So mostly if you say under normal condition, that is a straight road without banking, it is not possible. Why? Because if you take a turn, suppose you are taking this turn of radius r, right? This is the road. Now you will require what? Fc, that is mv square over r, which is the necessary centripetal force, correct? Now if there is friction, then this Fc is provided by friction, F mu. But if there is no friction, if F mu equals 0, no friction is available, then this turn is not possible, right? But with the help of what? Banking. With the help of banking, that is what? Making the roads at some angle, right? Say theta. Now you see what? You see the main problem that is overcome by banking is rain, ice, worn up tires, friction decrease, and car skids. These are few problems that are addressed by banking. So what we do is nothing but just tilt the road and the problem is solved. Let's see how. You see, suppose if the road is straight, And what happens? Suppose this is the car from the front view. Alright, this is the car front view. Now what happens here is, this has mg here and this is normal reaction here, and if mu equals 0, and if you take a turn, for turn friction f mu is equal to 0, so what happens? No safe turn as no centripetal force. Right, now if you tilt the road, at an angle say theta, now this is the road. Now how the car will look? The car will look like this, right? Now what happens here? The mg is again vertically downward, but the normal reaction n will be at an angle, right? Now with the geometry you will get this angle as theta. So let's resolve n. So we have here n sin theta and we have here n cos theta, right? Now you see, if this track have a turn of say radius r, this track has a turn of radius r, so we have what? We have mg equals n cos theta and mv square over r equals n sin theta, right? Here n sin theta, this n sin theta will provide necessary centripetal force. This is equals to fc is equals to mv square over r, right? So let's simplify. So we have, dividing the both equations, m cancel out m, n cancel out s, so we have tan theta equals v square over r g, right? So this is the theta or banking of road, or angle of banking, angle of tilt or banking. Here what is v? V is speed of vehicle, right? And r is what? Nothing but the radius of the turn. So what we have seen here is, even if friction is 0, vehicles can still turn safely, right? So even if friction equals 0, vehicles can still turn safely, right? Now in the cyclist video, what we have seen, cyclist leans to keep himself from falling, but if in the road banking case, a road is banked so that vehicle does not rely entirely on friction, right? Because friction is between the tires and tires can worn out easily, correct? So this was all about banking of roads. Thanks.